Hello, class. I'm going to give a brief overview of the parasympathetic division within the autonomic nervous system. This is considered to be craniosacral in origin, and the reason is because all of the preganglionic cell bodies are found either in the brain nuclei, that's the cranial part, or in the sacral spinal column, that's the sacral part. The parasympathetic division has many influences, and we often say cute little things like it's mostly in charge of your body when you're at rest. It influences greater digestion. It leads to the release of urine, micturition, the erection of a man's penis, and up-close reading or accommodation. There are 4 cranial nerves that are coming, or originate, I should say, from the midbrain, pons, medulla oblongata. Cranial nerve 3 is called the oculomotor nerve. Cranial nerve 7 is called the facial nerve. Cranial nerve 9 is the glossopharyngeal. Cranial nerve 10 is called the vagus nerve. Those are all preganglionic parasympathetic ganglia. They are again found in brain nuclei. You do not need to memorize specifically which brain nuclei they come from. The sacral part of the parasympathetic division is found in the sacral spinal cord at levels S2, S3, and S4. This special lateral gray horn is called the sacral lateral gray column. I abbreviate it in my homework packets as SLGC. All of these nerves have or give rise to terminal boutons that will release acetylcholine. I'll say it again. They all release acetylcholine onto the next neuron, which I will address now. So again, the preganglionic parasympathetic fibers release acetylcholine onto postganglionic cell bodies. These postganglionic parasympathetic cell bodies are called terminal ganglia, and they are found in the wall of involuntary effectors. What does that mean? I'll give one example. Terminal ganglia are found in between the epicardium and the myocardium of the heart wall. That's what we mean by within the wall of the effector. That was just one example. Because the upstream neuron releases acetylcholine, the downstream neuron must have a receptor that can bind to it. Specifically, these terminal ganglia have the nicotinic acetylcholine receptor. These neurons will release acetylcholine. They will release acetylcholine onto involuntary effectors, specifically smooth muscle, heart muscle, and glands. These involuntary effectors must also have an acetylcholine receptor. Specifically, they have muscarinic acetylcholine receptors. So the cranial nerve 3 oculomotor pathway, if it is stimulated, we would see the ciliary body allowing us, or ciliary body would now actually contract and would allow us to have nearsighted vision. We would see contraction within the smooth muscle, the iris, the sphincter muscle specifically, and this would lead to a decrease in pupillary diameter. Cranial nerve 7 pathway, if stimulated, we would see increased salivary production from the sublingual and submandibular glands, and increased tears from the lacrimal gland. Cranial nerve 9 pathway, if stimulated, we would see an increase in saliva from the parotid gland. Cranial nerve 10 pathway is regarded by many physiologists as the parasympathetic division. It is the only cranial nerve that extends from the brainstem down to the thoracic region and even into the abdominal cavity. If this pathway is stimulated, we would see a decrease in heart rate, also known as a decreased chronotropy, We would see a decrease in diameter for the air passageways in the lung, which is modulated basically by smooth muscle and surrounding those air passageways, and we call that bronchial constriction. In the gut, we would see increased gut motility and increased release of digestive enzymes until we get to the left colic flexure, also known as the splenic flexure. From after the left colic flexure, distal from that, if we're going through the gut, now we would see the sacral lateral gray column pathway taking control. It would again lead to increased gut motility and secretions, say along the descending large intestine, sigmoid colon, rectum. It would target the bladder and would lead to micturition or bladder or urine release. And in the man, we would see an erection. A special notable I just want to briefly say, when it comes to erection, there is also another neurotransmitter that's involved, and that's nitric oxide. But that's a special scenario, and I don't want you to worry too much about that. This concludes our review of the parasympathetic division of the autonomic nervous system.